Hey there, this lecture is the continuation from the previous lecture. I had to cut that one short because it was getting way too long. And so in this lecture, we're going to continue on the topic of the query DSL. So let's move forward. So let me format this syntax a bit so it's easier to read. So inside of this must, we have these two match conditions, right? And this must belongs inside of this bool. There's, just like we have must, there's also something called must not, okay? So let me show you what that looks like. And I'm just going to sort of fix this. Let's just get rid of, that extra condition so we get more documents here. And instead of the computer course, let's just change this to accounting so we have more data to work with here. All right, and let's run this to see what gets returned. We get a total of 4 documents that get returned. So similar to this, let me add the other classroom. I'm going to say where room is, let's pick a room here. This is E7, this is E3, and this is also taught in room E3. So let me just say that room should be E3. And notice that I'm using lowercase because remember, the analyzer is going to turn everything that we send into a lowercase, and the documents that have been indexed are going to be indexed into lowercase. So it'll match properly. So let's hit play and notice that it's returning those 2 documents that are containing the word accounting in the name field, and the room value is E3, okay? So these have 2 professors. There's a Thomas Bezos and there is also Bill Cage. So if I wanted to add another condition inside of the bool, we have this must condition. There's also something called must not. So let me do that here, must not. And then I could specify that a particular condition better not be true. So let me just copy this syntax to make it easier. Inside of this match, I can say that for example, the name of the professor should not be Bill Cage. So I could say professor dot name, right? Remember, this is a nested field inside of the professor object. So I could say professor dot name is Bill, for example. So I'm saying must not match this criteria. That's what this is showing. So let's hit play, and notice now the results. It's only showing 1 hit, and notice that the only professor we got here is Thomas Bezos, and the Bill professor named Bill is no longer being shown the search result because of this must not criteria. So we've got must and must not, and they are both inside of this bool expression. So just like we have must and must not, there's also something called a should, okay? And that just goes like this. And inside of this should clause, we specify what, ideally what should be there, right? It doesn't have to, it's not necessary. It's not a must or must not. It's just a should, meaning, it would be nice to have. That's what should means, right? So I could say, let me just copy this to make my life easier. And the name for this course we can say is computer. So now we're saying it would be nice for documents to contain the word computer in the course name. All right, so we'd like to see that. So let's hit play. And notice that it didn't give us anything, okay? The reason is because this should does not take precedence over must and must not. It's pretty much almost always ignored by Elasticsearch. Unless we specify a special field, we have to specify something called minimum should match. And we specify 1. And this means that the must and must not, that better be true, but the should must also be true. Because we put this minimum should match equals 1, we're enforcing the fact that the condition inside of the should better also be true. And how many conditions better be true? We're just saying 1. So 1 of the should conditions that are specified better be true. That's what minimum should match is. So it turns the should into sort of a must for 1 of the conditions that are specified in the should. And we can have multiple shoulds in here. I can put multiple shoulds in here. It doesn't really matter, and they could all be shoulding different types of criteria, but minimum should match basically states that at least one of these better match, okay? So let's get rid of those extra shoulds. So minimum should here is saying that, hey, this is actually also very important. So let's hit play, and now malformed, I made a mistake. This minimum should match field should not be, inside of this query. It should be actually inside of this bool clause, okay? So let's put a comma here and just put minimum should match equals 1, and let's hit play, and notice it didn't return a single document. It didn't return a single document, okay? And the reason for this is because we're saying that the name of the course must be a computer here, right? This should is effectively become a must because we added this condition, minimum should match equals 1. And we're also saying that the name of the course must also be accounting. So how is that possible? How can a course have the name accounting and then also the course name better be computer? That doesn't make sense. A course has a single name. So this is, of course, logically inaccurate. This is pretty much nonsensical if you really think about it, right? It would be the same thing if I was to take this out of the should and put it into the must, right? And we're saying now that the name of the course is accounting. It better be accounting, and the name of the course better be computer, right? This is not an or, okay? This is a must. This is saying that the name must be accounting, and it's saying that the name must be computer. So that's not even possible. Just to prove to you the point, if I just get rid of this should condition altogether and just run this as it is, notice it doesn't return a single document because this is just inaccurate logic. So let's revert back to the way it was. I'm just going to bring the should back there and turn this back to the room is E3. And let's put a should clause that makes a little bit more sense, okay? And now just to see the actual data, I'm just going to remove this condition completely for a second. And let's just get all of the accounting courses that are not taught by Bill. So there's just 2 of them. We've got Accounting 101 and this tax accounting. They're both taught in different rooms, E3 and E7. So I can have the should clause and say that the room is, it should be E7, okay? And if I add a minimum should match 1, that's going to only return this document, okay? So let's hit play. And notice that it's only returning the tax accounting course 200 with E7. If I get rid of this minimum should criteria and just have a should, which is saying, hey, it would be nice to have E7, then of course, it's returning both. E7 is there as well as E3. So play around with these conditions. I know it can get a little confusing, but the only way to get around this is to practice. When I was implementing Elasticsearch, in production, it took me a couple of months to get my head around this entire syntax. Of course, I wasn't studying it as much as I should have back then, but I've been using it for a while, so I'm pretty well versed with this query syntax. So make sure you're putting in a lot of time to get the practice. Learn this query syntax. It's very important. The must not, should inside of the bool that is inside of the query. This is the overall DSL structure. We can't change this, right? If I change this to should not, this property doesn't even exist. For example, if I play, it's going to say, hey, what is should not? It doesn't exist, and thank God it doesn't. So Elasticsearch has these defined parameters. So you just go through the DSL and practice these different query parameters and the structure of this query DSL, okay? So let's hit play so we can get that other document again. The next thing we're going to talk about is something called a multi-match query. It has its own, properties. So inside of, we of course need the query, and inside of this query we're going to put the multi-match clause. So it goes like this: multi-match, and this is of course going to also be, everything is JSON. So in here we specify the search criteria that we want to search over multiple fields. Okay, so we specify the fields that we want to search over. And this, of course, needs to be in quotations, right? Let's get rid of the extra quotes there. This fields clause is actually going to contain a list of fields that we want to search over. So let's say we want to search over the course name and the professor's department. So we could do professor.department, right? And then we specify what we want to search in these fields. And that goes into this clause called query. And we specify the string that we want to search for. So let's just search for the accounting string. So this means that this word accounting should exist in either the name field or the professor.department field. And if this word is contained in both of those fields, then that, of course, that document is going to have a higher relevance, right? So let's hit play, and this will give us those professors that work in the accounting department and that have a course that with the word accounting in the title. And it doesn't need to be a must for both of these fields. As long as one of these fields has this accounting term in it, whether it's name or whether it's the department of the professor, that document is going to be returned. And the documents that contain the word accounting in both of these fields, such as name and professor.department, those are going to be scored higher, right? They're going to be more relevant. For example, the first document here, Accounting Info Systems, it has accounting in the title, and guess what? The department for the professor is also accounting. So look at the score here, 1.2. And you can see the max score for all the hits is, in fact, this particular score. So it's sorted based on score. The highest one is on top, highest document. Now going to the next document, we've got cost accounting, and this is also pretty high up. It's almost a 1 in terms of scoring, and notice the department is accounting. Keep going down, and this is the accounting course 101, but the finance, the department is finance. So this has a lower score, and then keep going down. The lowest score here is this document with the department finance and the word accounting in it, right? So notice that tax accounting 200 is a long phrase, whereas this accounting 101 is not as long of a phrase. So the word accounting has more significance. It takes up more space in this field than the word accounting in this field. So this has slightly more significance than this one. That's why this is slightly more relevant. But of course, the most relevant documents are going to be those that contain the word accounting in both the name field as well as the professor.department field, as you can see above, okay? So we went over multi-match. There are other types of properties like these. Like, for example, there's something called a match phrase. So let me put that here, match phrase. And here we can get rid of this. We don't need that. The match phrase is going to match a sentence or a part of a sentence. So for example, we can say match phrase for course description, all right? And the course description better contain a phrase. And what is that phrase? We could just pick any old phrase here. So for example, let me just pick one of these phrases. So here, from the business school taken by final year up to this point. Let's just copy that and put that in the course description. So now if I run this, it should only return me this document with the ID 6. So let's hit play, and there you go. The total hits is just 1, and the ID of the document is 6. And notice that's what the description contained, this particular phrase. Now, if I cut this short, all right, and break a token, like for example, the word final is considered a token, but if I break into that token and just say fin, this query is no longer going to match. Let's hit play, and notice it's not working. The reason is because this match phrase takes each one of these as tokens, all right, and searches for them in the documents. So this fin is not really a complete token. Final was, but this doesn't understand it. So instead of match phrase, we could use something called match phrase underscore prefix. As you can see, it actually gives that suggestion. This tool is very handy. So now let's hit play, and there you go. Now it's actually bringing up the same department. So partial tokens can be figured out using the match phrase prefix. If we just use match phrase, we need to make sure that the token is complete. The entire sentence doesn't need to be complete, but you can't have partial words missing like that, all right? So that's match phrase and match phrase prefix for you. Let's continue on. There's also something called a range query, right? If we want search for documents that are, that exist in within a given range. So for example, let me get rid of this match phrase. Inside of the query, we can give something called range. And then inside of the range, we need to specify the field that we want to do a range query on. And that's going to be, for example, we have student enrollment numbers, right? Students enrolled in each course. For this one, it's 31, but other courses have more or less students in there. So I could just say, student enrolled and pick, greater than 10 and less than or equal to 20. That's what this GTE means. This stands for greater than or equal to 10, and then it goes up to 20, which is less than or equal to. So this is a range that includes the numbers 10 and 20. So let's hit play, and there you go. This is going to show 4 documents. All of these have student enrolled, 19, 17, 13, 18, basically anything between 10 and 20. Let me change this to 30 and hit play, and notice we get a total of 6 documents returned now. And there are, students that are, for example, this course, Accounting 101, has 27 students. This one has 22 students, and so on. So you can play around with these ranges. This is greater than or equal to. There's also greater than, right, which is just GT, and less than LT. Okay, this is also, if you don't want to include the range, such as 10 and 30, it's only going to check for greater than 10 and less than 30. Okay, so let's hit play, and that's, it's for this situation, it's still going to return a total of 6 documents because we don't have these numbers 10 and 30. But for example, if I say greater than 19, let me change that here, 19, and less than 27, right, then this document with the ID 1, this document above with the ID 8 are not going to be part of the result. So let's hit play, and notice it's only returning a total of 1 hit. Student enrollment is only 22 here. So just like we're doing a range here on a numeric field such as students enrolled, we can do ranges on dates. For example, course published date. There's another field you can do ranges on, and it works almost pretty much exactly the same way as it's working here. We just specify the given date. So let's try that. We could do course publish date, and we could say greater than, let's just give an arbitrary date, 2013 08, and I'm just going to give the same exact date that I see here, 27. And we don't need to have this less than criteria. We could just say just greater than, anything greater than this date. So let's hit play, and this is going to give courses that are more recent, right? More recent than this date. So take a look here. We got 2014, 2016, 2016, and so on, right? 2015 and 2014, 2015, okay? So this is greater than, but if I do greater than or equal to, that's going to include this date as well, the course that was published on that date. And hit play, and there you go. Let's go scroll down to find that course with that date, and that's this guy right here, okay? Where this can get quite complex is when you're combining these queries, right? We talked about the range query, the minimum, should and must not. You can actually combine all of these queries together and put these inside of other, musts and shoulds and so on. And that can make things kind of complex. But if you look at the structure as sort of a tree, you'll come to realize that it's somewhat simple. We've got query, and then inside of the query, we can have other kinds of queries, and those could further have other kinds of queries. So let me go over an example that will make more sense. Let's get rid of this, and let's specify a query that is going to be a bool query, and inside of bool, we'll have a bunch of, we'll have musts and should and so on. So we could say must give the array, and inside of this, we can say must match the name of the course with accounting, and close that bracket there. So that's our must clause, and then after must, we can have a must not as well. So let's do that, must not. And inside of the must not, we could say, it must not match room E7, for example. And this, of course, needs to be wrapped into curly braces as well. And then finally, we could do a should. All right, let's make this should a little bit more complex. We just looked at range, so let's do this. Range over a given field, we'll say, we'll do student enrolled. And I'm not even sure if this is going to return a result, and we'll inspect the documents that are returned here for this query. We could do GTE greater than or equal to 10 students and less than or equal to 20 students. So that's all part of, this is all part of the should. So we've got a range inside of the should. Like I said, you can combine these queries. You could put queries within queries. So we can have a range query inside of a should. We can have other types of queries that we mentioned so far in this lesson inside of these, musts and must not and should and so on. And we've got an error. And the reason for that is because inside of the should, like you see here, must not and must have this, these curly braces, and within there are all the queries, the match queries. So within this should, this range query better also be wrapped into this into these curly braces. I think that's it. So let's hit play and let's see what happens. And it looks like it did not parse. So sometimes you want to test whether this is valid JSON, right? And it looks like it might not be. So let's just copy and paste this into a JSON editor. And you can Google this. Let's just try JSON lint. I think I've used this one before. So click that, and then let's try this one right here. So paste your JSON here and click on validate, and notice that we've got an error. And it shows exactly what the error is. Notice in the match for the must not, we have the room, but we don't have the colon after that. So let's add that colon and validate just JSON, and now it's working. So this tool is pretty handy. Just use any old JSON editor online. You can Google for it. I use JSON lint. It's very easy to use. So we figured out our problem. It's this guy right here, room. Let's add the colon, and that should make things work. And there you go. All right. So notice the course name is accounting, right? It contains that, and it's taught in E3. It's not E7. Remember, must not. It must not be E7. So E3 here. So far, we're so good. And then the range for the student enrolled, it better be between 10 and 20. And here we are. This is 19. And let's go down. This is also taught in E3, and students enrolled, the range is 27, right? So notice this is just a should. It's great to have. This document is still showing. So what is more relevant here? The first document, because it's accounting for the should clause here, students enrolled 19. That's the ideal situation. So the relevance for this document is higher, but should is not an enforcement, it's just an ideal situation. So the second document here does not fall within this range. So it's shown as lower in terms of relevance for what we are looking for. Okay. So shoulds are very useful for ordering relevance. So this document above is more relevant for our search criteria. Now, if we wanted to make this should a must, right? If we want to make this should a must, what would we have to do? Take a moment to try that out on your own. Take this as an assignment. Modify this JSON structure so that you can add that particular attribute to this JSON so that the should becomes a must. So try that out. Pause the video now, and then you can resume to watch my solution. All right, welcome back. Hopefully you took a shot at completing that. It shouldn't have been too hard. Inside of the bool clause, just put a comma and put minimum should match. Right? Let's just get minimum should match and just put that 1 there. And now that's going to target only those documents that are within this student enrollment range, which is 10 to 20, along with these two, right? These must also be true. So let's hit play, and there you go. The total documents returned is just 1, and it's that document with the 19 students. All right, so we worked through a lot of examples delving into the query syntax, the query DSL. So this lesson, as well as the one before it, is quite comprehensive. So go through these topics to master this query DSL before moving to the next lesson. Remember, like I said, Elasticsearch has two major query components for the search DSL. One of the query components is the query, right, which we've been talking about throughout the last, this lesson as well as the last one. The other major component is the filter, which we have yet to look at. And I'm going to introduce that to you in the next lesson. So let's wrap up this section. I will see you in the next lecture. Thanks for watching.